very good morning, children. Today we'll continue with our fourth chapter, that is carbon and its compounds. So we have learned how versatile this element is, carbon in particular. We have seen the reasons why it is so versatile. And please children, do frame a question for about 5 marks regarding why the carbon is considered, or it is so versatile and so unique. Okay. So today we'll be learning about another very important point regarding this carbon, that is, it exists in more than one physical form. So these kind of forms are actually called as allotropic forms of carbon. Allotropic forms of carbon. We'll be learning about them now. So as you know that carbon exists in two forms. So occurrence of carbon is in two states actually. It exists in the form of free state, where carbon is pure. Free means it is not in combined state with any element or compound. So it is in free state. Like you can see here, these are nothing but the allotropic forms of carbon, children, where carbon is present in a pure state, in a free state. So it exists in more than one physical form, not just one form, but more than one physical form. That is actually called as allotropic forms. So diamond, graphite and Buckminster fullerene, these are the three allotropes of carbon element, children. So chemically these are all carbon only, they contain carbon only. Carbon, because it is a moderately reactive element, it reacts with different things and it is present in the combined state in the on Earth also. Like you can see that in atmosphere it comprises to about 0.03%. Okay, it is present in the form of carbon monoxide or carbon dioxide. In the Earth's crust also it is present in the form of carbonates, children. What is that? It's like limestone or marble, calcium carbonates, isn't it? So in the form of carbonates also it is present in the Earth's crust. And fossil fuels, the petroleum products, they are all hydrocarbons, right? So even oxygens, like in atmosphere we have carbon dioxide and carbon monoxide. We have other biomolecules, which these are nothing but the organic compounds which are present in the living organisms, like the carbohydrates, the nucleic acids, the proteins, the vitamins, etc. So carbon, today we will be learning about the free state, how carbon exists in free state. As I already told you that any element, if it exists in more than one physical form, we call such forms as allotropic forms of that element. Here today we will discuss about allotropic forms of carbon. So carbon exists mainly as diamond, graphite, diamond and graphite are the main allotropes of carbon, which were long back they were discovered, and recently there is one more carbon compound that is discovered recently, which is Buckminster fullerene. We are still, it is under investigation. Many things are yet to be found out, and it is just known. Okay, few things are known about this compound. It's also called as C60 because it's a molecule, a huge molecule containing 60 atoms of carbon arranged in the form of a football, actually, children. So you know how football is. You have pentagon rings and you have hexagon rings. So each vertex of this hexagon and pentagon are occupied by carbon. They contain carbon. So in that way, you get a football shaped molecule which contains 60 carbon atoms. So it is fixed. The number is fixed here. So it is Buckminster fullerene, children. Okay. Now coming to the diamond and graphite, we have many studies were done on these two things, and we now know many things about diamond and graphite, which we'll be learning. Few we'll be learning in our chapter. Let us see the structure of diamond. First of all, the physical properties of diamond. What is diamond? It's a colorless solid, compact and very hard substance which has a brilliance. Nothing but it's called as a chamak in Hindi. So the luster, it is a non-metal, yet it has got a very nice luster. It is very bright and it has that particular shine, isn't it? So what makes diamond so hard? So ultimately, all the physical properties that a particular substance shows up is a reflection of the chemical composition only, right? With what elements that particular substance is made of, and in what arrangement, what is the alignment, all that we need to learn. So before we go into that, we need to know more diamond physical properties, like we know that diamond is a bad conductor of electricity and a bad conductor of heat also. The reasons also is we can find in the chemical the structure, okay, the composition and the arrangement of these carbon atoms. Diamond is pure, it is a pure form of carbon. That means no other element is present except carbon in it. So and it's got a very high melting point also. The melting point of diamond is about 3500 degrees Celsius. What is the melting point of diamond? It is 3500 degrees Celsius. So what makes it have that high melting point? It is the arrangement. The answer is in the arrangement of the carbon atoms. And it is also the hardest substance known, isn't it? So let's just, if you burn this diamond, if you burn the diamond, ultimately, to very high temperatures, ultimately what you get is nothing but carbon dioxide. Okay, carbon dioxide means when you burn in the presence of oxygen, the carbon, it's nothing but it has only carbon. So it combines with oxygen and carbon dioxide will be formed with the liberation of lot of heat. So this is what is, it tells us that diamond is a pure form of carbon. Let us see the structure very quickly. Here the structure of a diamond is very compact. We don't have a fixed number of atoms as in case of Buckminster fullerene here. It has only 60 carbon atoms, but diamond is not like that. It can vary in size. It can be small, it can be bigger. That means bigger the molecule, more the carbon atoms in it, right? So we don't have a fixed number of carbon atoms. And how are these carbon atoms arranged? The carbon atoms are arranged in this form, children. Very compact form. As you can see, it is called as a tetrahedron, a regular tetrahedron structure. That means if you see this structure, this particular carbon, can you see here? This carbon, each carbon in the structure is paired or bonded to 4 different carbon atoms. As we know that carbon is tetravalent. It can bond with 4 different atoms. Now in this case, what is happening? Because it does not have any other atom, it binds with carbon atoms. So each carbon atom binds with 4 different carbon atoms. Okay, you can see over here 4 different carbon atoms. You can see this carbon atom is bonded to how many carbon atoms? These round balls also are carbon atoms only. 1, 2, 3 and 4. In that way, if you consider this carbon atom, can you see this? This carbon atom, 1, 2, 3, 4. In that way, this also will bind to 4 different carbon atoms. 1, 2, 3, 4. This also. Can you see this? 1, 2, 3, 4. Like that, each carbon atom, it binds with 4 other carbon atoms. You can see, you can go on stretching this, extending this structure. This one again, you can just pull it out and you can draw tetrahedron structure like this. A carbon, it is paired with 4 different carbons. So in that way, a huge 3D molecule is formed, in which each carbon atom is bound to 4 different carbon atoms. So now you can understand that the valency is satisfied. It has like 4, it has to get 4 electrons for getting stable electronic configuration. It is binding with 4 different carbons with covalent bonds, right? So all the 4 electrons are shared. So it does not have any extra electron. To conduct electricity, we know that to conduct electricity we should have free electrons, because in solids the electrons are conducted through these electrons only. When any substance does not have free electrons, it cannot conduct electricity. So it is very sure, very clear from this that because each carbon atom is just, all the 4 electrons are shared and it is in bonding, they are all paired, it does not have any free electron. That is the reason why it is called a bad conductor of electricity and heat also. Okay. So this is the reason, children. What is the main things you have to understand here is, it is a regular tetrahedron structure. Now coming to the graphite, children. You can see that graphite is also a pure form of carbon, but the physical properties are, chemically it is also carbon only, but physical properties are in contrast, like they are contrast or exactly opposite to that of diamond. It is very lustrous. It is just dull substance in comparison to when compared to diamond. It is very dull. It has got its very dull or what you call a very light grayish shine, but that's not as brilliant as this diamond. So you can see that this is now, it's not the hardest substance, it is the softer. It's softer when compared to other metals and non-metals. Actually, this is diamond. It is comparatively very softer. The reason lies, and also it is like a good conductor of electricity also. This is a bad conductor of electricity, and graphite is a good conductor of electricity. So the reason lies behind the arrangement and pairing of carbon atoms. Two